Okay, ladies and gentlemen, we're going to start talking about inverse relations and functions. Just as a reminder, a function is a graph for which every x has one and only one y. The way you test if something is a function, if you do a vertical line test. Now this, of course, passes a vertical line test. Now you say g of x squared of x. Well, that passes a vertical line test too, doesn't it? Well, sort of. Because really, if I take the square root of 4, my answer is going to be plus or minus 2, because 2 times 2 equals 4. Negative 2 times negative 2 equals 4. So really, this graph looks like this, because for any value 4 of x, I have either positive 2 or I have negative 2. But because math people don't like things that don't make sense with their rules, we said, ooh, that's a problem because that is not a function. If that's not a function, we're going to make it a function by ignoring the bottom. And by ignoring the bottom, we now have a nice, pretty square root function. But in reality, you do this. Now, if you graph it on your calculator, it's also only going to do that because what this is by default, the red graph is positive of the root x, and the brown graph here is the negative of the root x. But if we were going to take any number and square root it, you would have to deal with both the positive and negative. Now, I've chosen these two functions because if I have a squared and I have something like x squared equals 16, the way I would solve that problem is I would square root both sides. X could equal plus or minus 4. Over here, if I had the square root of x equals 3, the way I would solve for x is I would indeed square it. The reason I would do each of those things is because square is the inverse operation of square root. Square undoes square root. Square root undoes square. So in either case, these operations undo one another, much like addition is the inverse of subtraction and subtraction is the inverse of addition. Division inverse of multiplication, multiplication inverse of division, and so on and so forth and so such. Okay, so we get that they undo one another. Well, what we need to talk about now is how I can undo something a bit more complicated than these two. If I have something as follows, I have f of x equals 3x squared minus 7. If I wanted to undo this function, I think we could all agree that somewhere in that new function is going to be a plus 7 because that's the opposite of minus 7. Somewhere in that function is going to be a divide by 3 because there's a times 3, and somewhere in that function is going to be a square root. The question is, in what order do those things happen? What's the order that everything has to take place? Well, the way we find an inverse of a function is we say, fine, well, if f of x could be replaced with y, now I can simply do this one thing one and only one time in math, and that's when I'm finding inverses. I can literally take this y and this x, I can rip them off the page and juggle them around and put them backwards. So in this case, I'm going to now have x equals 3y squared minus 7. This should undo this because this is exactly backwards of this. Now you say, I can't leave it x equals. That's no good. I can't graph that. So we're going to solve it for y. Add 7 to both sides. So I have x plus 7 equals 3y squared. Well, of course, then I'm going to divide by 3. And then to get rid of the square root, or square, I'm going to square root. So my answer is y equals the square root of x plus 7 over 3. and it includes all the things we thought it would, and now we know what order they're included in. But just like I could change f of x to y, since I've reversed these, this isn't really y anymore. We're going to call this f inverse of x. F inverse of x equals square root of x plus 7 over 3. Now, ladies and gentlemen, I want to clarify something for you. I want to clarify that f inverse of x does not mean f of x to the negative first. F of x to the negative first means 1 over f of x. But you'll notice the negative 1 here is at the back. This negative 1 is after the f, before the x. This is saying do the inverse of the function of x. So f inverse of x does not in any way equal 1 over f of x. So let's review. Inverse operations. To find an inverse, we take any function, and we take the x and the y, we rip them out, we switch them around, solve for y, that gives us the inverse. By the way, sneaky little thing, g of x up here isn't really necessary notation, because if this is f of x, I say y equals x squared. Let's find the inverse. X equals y squared. To get y by itself, we square root, so the square root of x equals y. So this really is the f inverse of x. Now, you say, well, that's all well and good, but how can you prove to me that those are inverses? Well, if an inverse truly undoes one another, what I can do is the test as follows. F of f inverse of x. I can take its inverse and insert it inside f. So just like we learned in the last section, I'm going to take, since f of x is x squared, it's something squared. Well, what's the something that's squared? Square root x. Well, what happens to a square root and a square? They cancel out, leaving just plain old x. If I have a function and its inverse, and I do a composition of functions, I will be left with x and only x. Well, let's do this. If I have f of x equals 3x squared minus 7, and f inverse of x equals the square root of x plus 7 over 3, I want to do the composition. So I'm going to say f of f inverse of x. And so I'm going to say 3 something squared minus 7. The something is square root of x plus 7 over 3. Well, what's going to happen to the square root and the square? They're gone. Times 3 divide by 3. They're gone. That leaves me x plus 7 minus 7. Those are gone, leaving me just plain old x, and those must be inverses. By the way, I could do f inverse of f of x. It doesn't matter whether it's f of the inverse or the inverse of the f. Either way should equal x in the end. Okay, we've talked about the inverse as something that you can do symbolically with x's and squares and things like that. If we have something that's numerical, I have some function where I have f and f of x, and I have 1, 2, 3, 4, 5. And I have a t-table that says 1 goes with 6, 2 goes with negative 3, 3 goes with 4, 4 goes with 7, and 5 goes with 8. If I want x and its inverse, very easy to do numerically, because all I do is put what was y in the x column and what was x in the y column. Reason being, remember when we did our actual solving, we simply took x and y and we switched them. Well, if you take x and y and switch them, not shockingly, the x column will simply trade places with the y column. Now, that has an interesting idea when it happens graphically, because you'll notice x squared is a parabola this way. Square root of x is just that same parabola, but it's been turned. Now, technically it's not been turned, it's been flipped, because for whatever values I had for the original function, 1, 6, 2, -3, 3, 4, 4, 7, 5, 8, when I have the inverse, you switch the columns. So it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, comma 1, -3, 1, 2, 3, comma 1, 2, 4, comma 3, 7, comma 4, and 8, comma 5. And you'll notice I took what was standing up here and it's now flipped over. In fact, it's flipped over the line y equals x. If we take a look at this graph, it should be, if I've drawn it correctly, symmetric around, perfect mirror images around the line y equals x. And that makes sense because remember, symbolically, to find the inverse, we simply take x and we take y and we switch them. So graphically, it flips over the line y equals x. Numerically, the x and the y columns flip. Now, you'll notice this brown graph is a function, and I can test it by the vertical line test. The red graph is not a function. Good, good. Oh, it fails right here and here. Okay, it's not a function. You say, boy, it would sure be nice if there were a way to test this without having to flip the function before I test it. Well, if I take any function and I want to say, is this a function? Yes. Vertical line equals function. If I wanted to see, is its inverse a function? I'm going to use the horizontal line test. Is this a function? No, it touches in more than one place. So horizontal line tests the inverse, vertical line tests the original. Okay. Okay, ladies and gentlemen, here's your homework. Given f of x equals this, I want you to fill in this t-table. Then I want you to give me the inverse of that t-table. I also want you to find the graph of this function. You should be able to do it. It's going to be shifted over 2, up 1, tighter by 3. Then I want you to find the graph of its inverse by flipping it over the line y equals x. Finally, I want you to switch the two variables and find the equation of the inverse. Make sure you write it down and have it ready to go.